Hello aspirants, welcome back to the another session of Assistant Electrical Inspector. So in previous lecture we have discussed concepts of current, voltage, power, power factor, energy, resistance, specific resistance, temperature coefficient of resistance. So today we are going to discuss cells and batteries associated problems. So problems I will take in next session, that is part 3 I will make for the problems. Then we will go with magnetic circuits, electromagnetic induction, EMI, AC fundamentals and AC circuits, single phase and polyphase. Okay, so let's get started. So before starting cells and batteries, so one thing I forgot to explain you in the last video is that laws of resistance. Okay, let's discuss that. Later we'll move on to the cells and batteries. Okay, what are the laws of resistance? We know that R equals to rho L by A. Okay, this is we know. Unit is ohm. Okay, here rho. So here we can say that first laws of resistance, first one will comes. So rho is what? Resistance of a conductor is depends upon specific resistivity. Okay, second thing we have resistance of a material depends upon length of the conductor. Okay, so if we talk about next, so it also depends upon cross sectional area, okay, of the conductor. So these are the laws of resistance. Okay, let me take a conductor and let me give you an example. Okay, so this is a conductor. Okay, so there will be specific resistivity, okay, or resistivity of this conductor that depends upon the resistance is depends upon the specific resistivity. Okay, so as specific resistivity increases, what happens? Resistance will increase. Likewise, if length of the conductor increases, okay, what happens? This is L, correct? So as length increases, what happens to resistance? Resistance increases. R increases as L increases. But whereas inversely proportional, okay, inversely proportional what? Cross sectional area. Resistance of a conductor is inversely proportional to cross sectional area of the conductor. Okay, as area increases, okay, this is A, as A increases, resistance will decrease. These are the laws of resistance. If we talk about Ohm's law, what it states? Ohm's law states that the potential difference, okay, what is potential difference? The potential difference between two ends of the conductor, okay, this is conductor, two ends of the conductor is directly proportional to the amount of current flowing through it. Okay, the potential difference between two ends of the conductor is directly proportional to amount of current. Okay, potential difference between any two ends of the conductor is directly proportional to what? Amount of current flowing through it, to the amount of, or simply you can say V is proportional to I, current flowing through it. Okay, remember this. simply we can say V is proportional to I, where R is what? Proportionality constant, that is resistance of a conductor, okay, conductor material. Similarly, how we have body resistance, likewise a conductor will be having a resistance to withstand with the current flowing, okay. So this is Ohm's law, V is proportional to I, you should remember this, okay. There will be a magic triangle, okay, so you need to remember that this is the magic triangle, okay. If you want to find anything, if you want to current, so I equals to V by R. If you want voltage, V equals to I into R. If you want resistance, V divided by I. You should remember this magic triangle, okay. To this will help in you to solve problems, okay. So now we will discuss about cells and batteries. Before moving on to that, so cells are related with chemical effect. So before that, we'll discuss about chemical, okay. What is chemical effect? What is chemical effect? Chemical effect is important effect. Due to this effect, when an electric current is passed through an electrolyte, okay, so what happens? It decomposes into the its constituents. Similar to this, magnetic effect of electric current is one of the major effect, without the application of which we cannot have motors, okay. Without EMI, electromagnetic induction, we don't have machines or motors. A current carrying conductor creates a magnetic field around it, okay, which can be compensated by using magnetic lines of forces, okay. So in this chapter we will discuss only about chemical, okay. So there are some liquids in which a passage of electric current is passed or accompanied by chemical changes. This effect is known as chemical effect, okay. So there are some liquids in which what happens, in which a passage of electric current is passed or accompanied by chemical effect or chemical changes. This effect is known as what? This effect is known as chemical effect. Remember this, okay. Chemical effect of what? Electric current. So once again, there are some liquids in which a passage of electric current is accompanied by chemical changes. This effect is known as chemical effect of electric current. The application of chemical effect of an electric current may be observed in daily life, like nickel, copper plating on metallic articles, okay, or production of EMF by SL. So if you talk about electrolyte, what is electrolyte? What is electrolyte? The liquid or solution which undergoes a chemical change, okay. Simply the solution which undergoes what? Chemical changes, which is nothing but electrolyte, okay. What is it? The solution which undergoes chemical changes in it, okay. When it goes to chemical changes, what happens? When a passage of electric current is passed, is called as electrolyte. So example for it, Electrolyte is salted water, then we have acidic or basic solution. These are some example of electrolyte. Okay. So, if you now we will discuss about electrode. What is electrode? So, electrode is nothing but what? The conductor plates are immersed in a liquid to form a passage of current flowing through it. So, this is a water. Okay. So, two electrodes are immersed in the water. Okay, to form a passage of current. Okay, through it. They are known as electrodes. These are electrodes. Electrodes. What is electrolysis? Now we will discuss about electrolysis. Simple concepts. Okay, these are simple concepts we should remember. So, many examinations will ask definitions. You may forget. Please know all these things. The process of chemical changes due to passage of electric current through a liquid or a solution is called electrolysis. The process of chemical change due to passage of electric current through a liquid or a solution is called what? Electrolysis. Remember this. So, I think you have understood what is electrolyte, what is electrode, what is electrolysis. What is electrolyte? Solution which undergoes chemical changes. What is electrode? What is electrode? Electrodes are two conductor plates which are immersed in a liquid or a solution. These electrodes are immersed into electrolyte. What is electrolysis? Process of these things. Okay, electrodes plus electrolyte is nothing but electrolysis. Simply. Okay. So, if we talk about next. Okay. So, next we have Faraday's law of electrolysis. Let us discuss about Faraday's law of electrolysis. There are two laws, Faraday's laws of electrolysis. You should remember the formula. Okay. First law. So, for your kind information, Michael Faraday was a chemist and physicist who gave the laws of electrolysis. Okay. So, first law you should remember this, M is proportional to I into T, or M is proportional to I Z T. Okay, I will explain what is Z. So, here with the help of this equation we can say that this law states that mass of an element free by an electrode is directly proportional to the quantity of current flowing through it. What it is? Mass of an element free by an electrode is directly proportional to the quantity of current flowing through it. Okay. This is first law. Okay, here where m is nothing but what? Mass of free ion. Then we have I, electric current in amperes. Okay, then we have Z, electrochemical equivalent. Remember this, electrochemical equivalent. So it is in grams per coulomb, grams per coulomb. So you understood the first law. So if you talk about what is electrochemical equivalent, okay, the electrochemical equivalent of a chemical element is the mass of that element transposed by 1 coulomb. Okay, what is electrochemical equivalent? A electrochemical equivalent of a chemical element is the mass of that element. Okay, mass of that element transported by 1 coulomb of electricity. Okay, is nothing but the electrochemical equivalent. So this electrochemical equivalent is measured, electrochemical equivalent is measured by what? Voltmeter. Remember this, remember this. Okay, what is the unit? Grams per coulomb. So if we talk about the next law, that is second law. Second law, what it says? Second law says that if the same quantity of electric charge is passed through different electrolytes, if the same quantity of electric charge is passed through different electrolytes, the masses of the substances deposited are proportional to what? Proportional to their chemical equivalent. Understood? What second law says? Equivalence. Okay, if the same quantity of electric charge is passed through different electrolytes, okay, there are different electrolytes, okay, same quantity of electric charge, okay, 1 coulomb, 1 coulomb, 1 coulomb, 1 coulomb flows through different electrolytes. Okay, these are different electrolytes. The masses of the substances deposited are proportional to their chemical equivalent. Masses is proportional to W. Okay, where W is considered as chemical equivalent. This is chemical equivalent. So M1 is proportional to omega 1, sorry, W1, M2 is proportional to W2, M3 is proportional to W3, or M1 divided by W1 equals to M2 divided by W2 equals to M3 divided by W3. Okay, I think you have understood the second law also. So if we talk about the chemical equivalent, the weight in gram of a substance that combines with the displaces in gram of hydrogen is called as chemical equivalent. So simply it will be difficult for you. So remember this: chemical equivalent is equals to atomic weight, okay, divided by what? Valency. Remember this, okay. This is what chemical equivalent. So now we will talk about chemical cell. What is chemical cell? So if you talk about the chemical cell, the device which uses chemical process to produce EMF. Cell means what? Battery. What it does? Chemical into electrical or EMF. So chemical cell is nothing but which converts chemical process into electrical energy or EMF. So which is called as chemical, or simply chemical energy is converted into electrical energy. Chemical energy is converted into electrical energy. Remember this, okay. So if you talk about cells, there are types of cells, okay, types of cells. Totally there are 2 types of cells, okay, primary cell and secondary cells. 2 types of cells, okay, 1, 2, primary cell and secondary cell. To know what is primary cell, okay, primary cell simply you will be having in your TV remotes, okay. Primary cell, chemical action is not reversible. Simply if you want to write, not rechargeable, okay. The cells in which an EMF is produced due to chemical reaction is called primary cell. In primary cell, chemical action is not reversible, okay, which means not rechargeable. Example, we have voltaic cell, lithium cell, okay. You might be wondering, sir, we have lithium cell in EVs, electric vehicles. So recently we have found some lithium cell particles at Jammu, like that. So that is lithium ion. There is a difference. Lithium cell is a primary cell which cannot be recharged. So whereas lithium ion cell is a rechargeable cell or a battery, okay. So then we have Daniell cell, we have Leclanche cell or dry cell. Dry cells you will be using in your TV remotes or toys, controlling unit, batteries, etc., or mercury cell, okay. So what is secondary cell? Secondary cell is exactly opposite to the primary cell. I will show you some examples, practical, okay. So how they look in practical, okay. So chemical effect or chemical action is reversible. So simply you can say in our words, rechargeable batteries or a cell, rechargeable. So rechargeable, we know that our cell phone's battery, correct. So examples if I talk, Secondary cells are nothing but lead acid cells. Okay, I will show you. Nickel iron cell, then we have nickel cadmium cell, nickel cadmium cell. Okay, I will show you practical example. So here you can see these are what? Dry cell or category of primary cell. Okay, so you might be seeing in watches, correct, in your wrist watches. So in wall clocks you will be using these kind of what? Cells. Okay, so what is this? Lead acid cell. Okay, so this is nickel cadmium, then this is what? Nickel iron cell. So these are all called what? Secondary cells, which are rechargeable. Understood? So okay, so before going to that, let me tell you here one thing. So these are some popular cells. Okay, dry cell, so we will be having internal resistance or internal of 0.2 to 0.3 ohm. You should remember this. You might be asked in examination, and it will be having EMF of what? 1.5 volts. Okay, this you should remember. So it consists of cylindrical zinc container. See here you can see cylindrical zinc container. Okay, so this terminal is called positive and the bottom is called as negative terminal. So at the middle of the container a carbon rod is fixed, which works as a anode. Around this carbon rod a cloth of punch containing powder mixture. Okay, so we have lithium cell here. We can see here lithium cell, which is of 3 volts, which I have mentioned here. Okay, thin protective electronic insulating film is formed on the lithium anode, protecting the anode against corrosion. Okay, so this is what? Non-corrosion material they are using here. Lead acid cell. Okay, this lead acid cell EMF of the battery will be from 2.2 volts to okay, so it will be from 2.2 volts to so on. So it will be having internal resistance or internal of 2 ohms. Okay, so if I talk about nickel iron cell, what is the EMF? EMF will be 1.2 to 1.5 volts. For nickel cadmium cell it will be how much? So here cadmium plate is used to reduce the internal resistance. Okay, cadmium is used to reduce or internal. Okay, remember this. So now we will talk about battery. So just now we have spoke about cells, right? So here now we will talk about battery. What is battery? Connection of all the previous things. Okay, connections of cells in a group is called battery. Okay, number of cells forms battery. Okay, what is group? Group of cells, it may be series, it may be parallel, it may be series, parallel. This is how grouping is made to form an battery. Okay. So we can say that whenever more than one cells are connected in series or parallel or mixed group is called as grouping. Cells can be connected in series parallel or series parallel. So in order to know what is the capacity of a battery, okay. So what is the capacity of battery? We should know ampere hour. When someone says what is the capacity of battery, ampere hour. Why? Capacity of battery is defined as the value of current flows in a given time duration. What it is? Value of current flow in a given time duration. Remember this. Okay. So if I talk about its unit, just now I discussed, its unit is ampere hour. Ampere hour. Okay. Simply you can say ampere hour. See, if you want to see the capacity of battery, just if you are having a bicycle or a motor vehicle, just go and remove the battery panel, and where you can see the ampere hour written on the battery. Okay, that is the capacity of battery. So if I talk about efficiency of a battery, okay, efficiency of battery. What is the efficiency of battery? How the efficiency of battery is measured? Efficiency of battery is calculated with the help of two parameters. Okay, calculated with the help of two parameters. What are all those? Ampere hour efficiency and watt hour efficiency with two parameters. One is ampere hour efficiency. Okay, I'll write like this. Okay, next we have watt hour efficiency. I'll write short form. So if I talk about ampere hour efficiency, how to calculate ampere hour efficiency means ampere hour efficiency percentage is equals to discharging divided by charging into 100. So discharging in ampere hour, as it says, charging in ampere hour. Remember this. So if I talk about watt hour efficiency, what is watt hour efficiency? NWH percentage equals to discharging divided by charging into 100. Okay, here discharging what? Watt hour, charging in watt hour. Okay, remember this. So here we can write in ampere hour efficiency equals to ID into HD divided by IC into HC. Okay, this is formula. So if I talk about watt hour, VD into ID into HD divided by VC into IC into HC into 100. This is for watt hour. Okay, so battery charging. Now we will talk about battery charging. So after the construction of a cell or a battery, as I saw, as I shown here, so this battery has constructed. So charging of the cell is required. Apart from this, when the battery is partially or completely discharged, okay, partially or completely discharged, then it is charged again. For the charging of a battery, it must be connected with the DC source, okay. Some DC source should be connected to charge. If DC source is not available, then first AC is converted back to DC, then is given to this battery, okay. Then the battery cell. The different techniques are used for battery charging, such as constant current charging, okay. What are all the battery charging methods? Battery charging methods. Constant current charging, so another we have constant voltage charging, and trickle charging, okay. These are the battery charging methods. So I hope you have understood all the concepts whichever I have explained till now. So next, electromagnetic induction and AC fundamentals I will take in next session, because time constant is more. So I will try to prefer less duration of video, because if you see the duration of video, you will not watch the videos and you will simply skip the video. If the time is less, then you will try to watch the video. If you like this session, please share with your friends or aspirants who are preparing for the examinations, okay. Thank you for watching. See you until next session.